Hey, welcome everybody. Welcome LabVIEW friends and colleagues. Welcome to this edition of LabVIEW Live, a community user group. My name is Jeremy Marquis. I've used LabVIEW for over 25 years. I'm a certified LabVIEW architect, professional instructor, and LabVIEW champion. And I love getting the community together. Uh, we've had many community events over the years, and now we've gotten to go digital with LabVIEW Live. Um, I am also the engineering technical lead at G Systems, an NI Gold Alliance partner. And G Systems is a turnkey systems integrator with a focus on test and measurement, especially in aerospace and defense, energy, RF, and biomedical. All right, so let me tell you how this is going to work. When we had our in-person events, there was, of course, a lot of user interaction. So we're going to try to capture that as much as we can with this live event. So we encourage you to interact with your speaker and amongst yourselves. So to do that, we want to use the YouTube live stream chat. And so all of the presenters and moderators are all watching this chat, and they are ready to answer your questions live. If you are watching this embedded stream on the page sent in your registration email, there's a link right next to it to click the link to go to the YouTube site. That's where you will see the live chat. If your YouTube video is really low resolution, then YouTube itself has reduced it. You can set it manually using the gear icon in the bottom right of your video window. And just to give you a heads up, we will be officially ending the session cleanly, so we have a good recording for future viewers, but we will continue the discussion and Q&A after that close. In today's topic, we are going to be talking about how to handle inheriting a code base that is, shall we say, less than spectacular, strategies for improving it, and what you can do to benefit people that inherit code from you. So an introduction to our speakers. We have an all-star lineup today. These are truly veterans with decades of experience. Many of you know them. They are business owners, authors, and community leaders, and they are also a lot of fun. I can't begin to introduce each of them properly, so I will leave that to them. Our speakers today are Brian Powell, Steve Watts, Fabiola De La Cueva, and Jorg Hampel. And with that, I'm going to go ahead and turn it over to Brian.
All right, thank you very much. I was originally going to do this presentation for NI Week this year, and that got canceled. I was going to have a follow-up presentation at G Systems North America, and that got canceled. So this is kind of combine the ideas, and I invited my friends that are part of the DSH Workshops to join me and kind of help discussing this. I apologize for my dog barking in the background. He's been quiet all morning until now. So let's see. So this is gonna be interactive, and so there's a link at the very top of this slide. I don't know, hopefully you can see it. It's pollev.com/bhpowell. And so we're gonna be using that several times during this presentation for some interactivity, but I just wanted to start with, where is everybody from? So if you could go to that link, and then you can click on the map and show us where you're from.
I can already tell you from some of the comments that we had at the beginning, we have people from Brazil, Belgium, so we'll see if those little things start popping up on the map.
Yep, they're starting to pop up. That's awesome.
We're missing the one from Brazil. Or Ecuador, I think they said. Brazil or Ecuador?
Awesome, love to see this. Oh, Mexico, yay.
Yeah, that's probably Enrique.
Spain, Portugal.
Pretty cool.
Okay. Give it a few more seconds and then we'll move on. Okay, awesome. Okay, so I'm going to start with Our Giants Are Female. For those of you who are not familiar with that hashtag, go read Fabiola's post. I'm not sure where you posted that, Fabiola. Is it Women Who Code, something like that?
Yeah, I'll put it on the chat.
Awesome. So we just like to celebrate women in technology that have, you know, we've been inspired by or worked with, and just want to celebrate that. So for even though this is G Systems, Linda would be an excellent person to call out here as you know, founder of G Systems and also one of the members of the LabVIEW 1 team. But we've already featured Linda on an Our Giants Are Female. So I wanted to call out somebody else in the LabVIEW 1 team, Rosie Marotra. And so this is a picture of her at the LabVIEW 25th anniversary celebration we had a few years ago. And she was one of my mentors when I first joined the LabVIEW team. One of the claims to fame for her is she's the last person to release LabVIEW, a version of LabVIEW 1. And so while the rest of us were moving on to develop LabVIEW 2, she was tasked with getting LabVIEW 1.2 out the door. Some bug fixes and things like that. So anyway, I just wanted to give a call out to Rosie. She's a great engineer, and I really enjoyed working with her. Okay, so here's how we're going to be spending our time. Brief introduction to DSH and kind of what we're doing and why we're all involved in this. And then we're just going to kind of go into this whole open discussion about inheriting somebody else's code, because all of us have a lot of experience. One of the things is we're not none of us have code that we can share from our customers. We have a lot of good examples, but none that we can share that we can, because not all those customers want their dirty laundry aired. But we can certainly talk about the process and the topics and some of the things we've seen. And so we'll be doing that. And then, you know, kind of the main takeaways is, you know, how do you get comfortable enough with this to not panic and come up with a plan, and also leave things in a better state than when you found them. And so the kind of the as Fabiola likes to say, being kind to your future self, because sometimes you're the one who ends up having to pick up a project after several years. And so the kinder you are to the future, it can sometimes benefit you directly. As mentioned earlier, you can ask questions in the YouTube chat. And so I'll be picking out some of those for us to discuss as a group when we get closer. Okay, let's see what's next. So DSH Workshops. So that's this sort of loose consortium of these companies here at the bottom. So Delacor is Fabiola, SSDC is Steve Watts is there, Jörg Hampel's at Hampel Software Engineering, and then I'm at Stravaro LLC. And as Jeremy mentioned, we have decades. Steve added it up, over 100 years of real-world experience in developing software and fulfilling projects. That's another thing that all of us, you know, like to have good customers that we're happy with working with. And making sure it's meaningful to us, because that's how we prefer to be spending our time. So I'm going to let each person introduce themselves just so you kind of get an idea of who we are individually.
All right, so my name is Fabiola. I go by Fab. I've been doing LabVIEW for 20 years. And I am best known by being the lead architect for DQMH, the Delacor Queue Message Handler. There's also other things that that I do, like I wrote the LabVIEW Graphical Programming 5th edition, and those are the areas that are on the slide that are where I'm more passionate about, but I'm just passionate about anything LabVIEW, really.
Hi, I'm Steve Watts. I've been writing software since the 80s. LabVIEW since the 90s. Been doing fixed price projects since 2000, just before. We wrote the book, Software Engineering Approach to LabVIEW. Still quite proud of chapter 4. Everyone should read it. Yeah, the things I'm most interested in really are design and process and simplicity. I think simplicity is a good thing.
Okay, so I've been told to keep this brief. I'll try my very best. My name is Jörg. I'm an Austrian living in Germany. I've been living here for 13 years now. I've been doing LabVIEW project work, fixed price work, yeah, for many years. And recently we've started more and more working together with our customers, and that's what I'm interested in, trying to make the teams collaborate as good as possible. And like Brian said, with the least amount of headache possible. And that's what we do for a living right now.
Awesome. And I'm Brian Powell. I worked at National Instruments on the LabVIEW team for about 26 years in a variety of roles at NI. And then went and worked in healthcare for a few years, and then at a local startup for a year and a half. And then last year started my own consulting company back in the LabVIEW world. And so, yeah, it's been a lot of fun. It's been an interesting transition to owning my own business, but it's been a lot of fun. Okay, so next up, here's another poll. Words that come to mind when you work on somebody else's code. So you're assigned to a project to, you know, maybe take over some big legacy LabVIEW system. What goes through your head? What goes through your mind when you see that? And they can be positive or negative feelings. They're not always negative feelings.
I'm also entering words. I don't know if that's allowed or not.
What was that?
I'm also participating and entering words myself. I don't know if that's allowed.
Me too, and I've discovered
And
if you
of
do
course
really
now,
long
my
words,
headset decided to run out of battery.
Yeah, I like the dollar signs there because it can be very lucrative to work on messy projects.
Guess who puts them there?
Possibilities, I like that word too. Style, good. Frustration. Documentation, I thought was another good term. Documentation's big now.
the opportunity to improve. Yes, there you go. There's the modern management term.
I put there wonder, amazement, because I figured there were not going to be that many positive ones, but I try to figure some positive ones. There's colorful. You need to add colorful. If you're talking about yeah, there's also like I like to tell people that we are also archaeologists, right?
Yes, archaeologists, absolutely. Okay, so I'm gonna move on to the next thing. So kind of what our high level approach, and we're gonna talk about each one of these individually, is kind of assess the situation, which is different than assessing the code. Like, and so we'll explain what that difference is. And we want to kind of assess all of that stuff before we start modifying anything. And then there's the whole modification process, a lot of refactoring, things like that. And then there's the whole idea, well, what about the future? What are we doing to make things better for the future? We started to put together this outline for this topic, and I don't know, it quickly turned into a half a day or a day's worth of content that we could talk about. And so one of the reasons for the polls is to let you kind of guide what direction we actually talk about. And we'll just kind of work on one of these topics for a little bit, and then we'll move on to another topic, and then hopefully answer people's questions as we go. Okay, and a reminder to use YouTube chat for any questions that you have for us, and I can bring those up and we can talk about them. Okay, so when you think of specific situations where you have inherited somebody else's code, what are challenges that you've seen? Corrupted code, that's interesting. The challenge of schedule, yeah, a lot of times need to be fixed or improved immediately. Testing, we're going to talk a lot about testing. Performance issues, yeah, poorly designed or structured code, bad programming practices, lack of documentation, lack of common architecture. Yep, these are all, we're all nodding our heads in agreement with these things. And logical dependencies. Unsafe code, I'm kind of curious what you mean by unsafe code. Race conditions, yeah, UI and logic combined, I see that a lot. Ooh, VIs without block diagram. That's a challenge. Okay. So DSH team, you want to pick out one or two of these to start with?
Well,
go ahead.
I'll hit one that hasn't occurred. I did type it in, but I'm obviously a bit slow. But the one I think is fundamental to all of the projects I've had to go with, oh, there it is poor project management. And that's a thing you'll have to contend with right up the start. Is I would say a reasonably common factor of rescue jobs is that management bought into LabVIEW is easy and just thrown anyone at the project, and not then sort of manage them in any fashion. Maybe it's just a British thing, but I'm sure it isn't.
I think there's one even before project management, like even at the very beginning, is even why are we here, right? Like what is it that we're trying to solve? Sometimes they are calling you, and I had these situations. I actually have earned customers because they wanted me to refactor an entire program, and then I start asking, does it work? What are the problems that you're seeing? Do you have any bugs? What is it that you want to do? And they say, well, we only want to add one channel, but the computer is running Windows 95 and the code was written in LabVIEW 4, so it probably needs to be upgraded. So it's really like, first, do we really need to do this? And once you understand what is it that we're trying to solve versus what the customer is telling you they want to do, I ended up doing that project, even though it was all globals, for like 10 hours, which was just porting to all the different versions of LabVIEW and adding the new challenge. I held my nose, added a new global for the channel that they were adding, because this was done with LabVIEW 4. And then, that was it, instead of 250 hours that it would have been to refactor the code. So sometimes you have to look at not only what is the customer asking me to do, or what is it that I'm trying to do, is why, and what problem are we trying to solve. I think Steve said it really well, is at the end of the day, our code is a description of the solution to the problem we have. So
yeah, I think that's understanding why they hired you is a really important thing, because there's one company I went to work on a project where, ostensibly I was hired to fix a performance issue on logging some data. And then you get there and you see that the situation has more problems than that. And so that's where you need to, work with the local management and say, here are some other things that you should consider that should be fixed. And, I can just go in and change the, add this feature or, fix a performance problem, but you've also got race conditions. There's a question of whether you're even acquiring the data the right way. All these other things that can suddenly blow up for you. And so that's where you, you should be honest with whoever hired you about, what is it you really need and can afford to get done, and what about all these other problems? What's the plan for that?
And another thing to look into would be, who are you going to be working with? Meaning, like, is the person that created the code still there? Is it still part of the team? Are they left with code that nobody can maintain? Should you actually not only fix the application, but also show somebody how to maintain it afterwards? What is the expectation in that regard? And I think it's both helping yourself come up with the proper quotes, and also maybe a chance for upselling, because some customers might not be aware that you're also able to show them how to do stuff. And that's what we like to do the most, probably. So looking into who's around and who are you going to be working with.
Yeah, I don't know if it has to do with age or what, but like the four of us like a lot more to mentor someone and teach them how to fish than get them to work with us so we can push down their throats and the architecture that we think that they need to be using, and then force them to work our way. We like more to understand what is the situation around the program that we're in, the application that we're inheriting, and deciding really what is our role. But most important for us is to teach the people that are going to be owning the code later how to maintain it. Now, that's not always the case. Sometimes they just come back and say, no, really, I just want to pay you, and it's your baby now, right?
I want to expand on something that Jörg said about the people side of things. And so in our discussions beforehand, Steve had talked about, what happens when the person who wrote the big mess of code is still on the team and still part of that. So Steve, do you want to expand on that?
Yeah, actually, that's the trap or the bait I often get, and is can you come and just review the code? We just would like you to have a look at the code, make sure we're going in the right direction. And in my innocence, I used to say, oh, that's nice. I'll go in and I'll got all my code review stuff, and we'll go through it together, and I can show them how to do code reviews. And yay! I have never once had a code review which isn't either a weaponized method of kicking somebody out of the door, isn't a way of renegotiating a contract, or isn't a complete project management disaster that actually somebody needs to get the blame for. So it's a shame, because it's one of the most valuable things that you can do and get a consultant to do is actually do a code review. But I have never actually been in the situation where you go in and you say, oh, this is great, and everyone says this is great, because there's always some personal investment in that code base. And there's always either a management manager that's approved or even hired the person. And there's always, and we're brought in generally because there's an emergency on. You don't bring people like us in if things are going swimmingly, generally. Wish they would, but generally they don't. So the situations often need quite a lot of diplomacy, which is the point I'm getting to. And I was thinking of a case study, and I've got quite a good one. This was probably about 20 years ago. I used to work with a guy called Keith Martin, because that was his name. He's retired now, so it doesn't matter. And if you thought I was blunt, he's blunter by a factor of about 10. And
I don't think that's possible.
We walked around this factory looking at all their test systems, and essentially he spent an hour and a half going around going, why on earth did you do it like that? What on earth were you thinking? What's the decision that you made here? And at the end of it, we sat down in the meeting and I was mortified. We sat in the meeting, and the guys we walked around with said, yeah, we did all of that. And now you've got to, needless to say, we didn't get the job, but there's human factors involved in all of this and it's really a lot of the time due to investment in time. People go quite a long way down a rabbit hole before they call for help. So the rescue job has to bring you. Sometimes you have to bring it quite a long way back, and that involves, like I say, sometimes it involves some quite high-level diplomacy, shall we say?
I think also with time we start to learn that people get into weird situations, whether it was poor management or whatever. But some people take their code too personal, and that's a talk that Brian Powell normally does about saying it's not my code, it's our code. And one thing that I have learned with the years is that I used to be like, there is a way and you should be doing this way, right? And then I started realizing that, yeah, it was surprising for me. One of my customers would call me every 1 or 2 years with, all sites in Asia are down. We need you to solve this bug. And he was always like working extra hours. And I never understood why he wouldn't just hire me to clean up the entire thing. Why was it always as a firefighter mode? And it finally dawned on me that I was suffering for like 24 hours or 48 hours or a week or whatever, depending the bug. Some of them were hairier than others. But for him, the pain was only that week. The rest of the time, this thing was generating money. So despite how ugly I saw it and how much risk I saw on every corner of the code, he didn't see it that way because he would get money and things out of it for an entire year. And then every 1 or 2 years, he would get a week of excitement, I guess. So with time, I learned that within those days that I had his full attention, that's when I could insert some improvements, right? But as soon as I fixed the main bug, that was it. It was, yeah, we'll deal with it again later. It was always the same thing, but I learned to realize that our level of risk and our pain management is going to be very different. And what I consider unacceptable, he was totally fine with, and his customers were fine with. It was once it went past that unacceptable level that I would get cold. Unfortunately, very painful.
Yeah, one of the other things about people side of things is like one of the companies I dealt with, lost their main LabVIEW developer who wrote the system. So I'm brought in to come, make their customer happy for a few days. And I really wanted to fix some of their problems. They had a variety of problems, but a lot of them could have been fixed by adding a few object-oriented classes. But I knew that the team that was left behind did not know LabVIEW classes. And so even though there's like a good way to fix the problem that the customer was seeing, I couldn't in good conscience go create something that nobody else at the company could maintain on their own. And so, you have to figure out how do I work within the bounds of the existing skills of the team. And then I also made a recommendation to the manager when I left. It's like, it would be really good if you hired somebody who either knows LabVIEW classes or could be trained to learn LabVIEW classes. And that would improve their architecture quite a bit. And, it's just kind of up to them, then their management to decide whether to invest in something like that. We have a question in the chat from Kevin Shirey. Is there a preferred cadence to refactoring code over hundreds of projects? And so I think you're talking about, revisiting the code and deciding whether things needed updating. And what are some thoughts there from the team?
I think that's a risk and reward judgment, isn't it? It's you look at your projects, you look at the ones that are most worth your time, and you do your Pareto and give your 80% benefit for 20% time and just go for it like that. So it's I think if you're going across projects, I don't know. I think you could sort of say you can factorize common parts, can't you? But I mean, I would probably take a bit more of a project by project view and just tackle the ones you're getting the most hassle with?
I am more of refactoring as you go. So anytime that you're touching the project because you're adding new features, that's when you are there on the code. If it is something as you go that you see, okay, do I have the time within the aspect of adding this new feature? And the other thing is every time we add new features, trying to do it better than last time, right? Like, let me start with unit tests. Let me make sure I'm going to be doing unit tests. It's really nice to come back to support code that I inherited that originally was a mess, and finding myself less worried every time that I get called back to add a new feature, because I know that the last time I already added some safeguards, like a tester, an API tester, unit test, stuff like that. And it's always little by little, like in the example that I was giving with that customer that would call me every year or two, there was always something new the next time that I would be like, oh, I'm so glad I left that last time. Like the first time I got dev and source code control. The second time, I had a build server separated from the machine that they were originally building. Little things that every crisis made it more manageable for me.
My thought is that there might be 20 things that I want to change about this application, but I'm gonna, control my myself and try to just work on one at a time. We'll get to this when we start talking about modifying the code and refactoring, but you want to make sure you're not doing too much multitasking of a big refactor. You really want to, let's refactor one aspect of this application and make sure that things are still working, run our tests and so on. And then we'll go for the next thing that we want to refactor. And a lot of it is also driven by who's paying me to actually do the work. If it's just I'm doing it because I'm frustrated and I'm wasting time because it's messed up, that's one reason to spend on it. If it's just I don't really like this, then that's maybe less motivation to do a refactor.
We also tend to, if we have to learn what the code is doing, there are specific jobs that you can do within the code base that help with the understanding. So you can sometimes, rather than do the most urgent, you do the thing that's going to teach you the most about the code. It's actually the last couple of sort of comments was no clear requirements. Well, one of the first things you do is try and understand what the code is required to do and give it the black box, treatment.
Okay, so I'm gonna move on and kind of wrap up this section, and so we can move on to the next session. So kind of the summary here on assessing the situation is why are they bringing you in? What is the problem that your customer wants solved? And making sure you understand that, very clear on that, and what are the bounds of what you can work on. Dealing with the people issues of whether the person is still involved, whether they're really have their ego wrapped up in this code or not, and then how skilled the team is for the changes that you want to make. And then some of this we're going to talk about at the end when we talk about planning for the future. Okay, so next up is another poll about assessing the code. And so just talking about, okay, now we're in the LabVIEW environment and trying to figure things out. What are some of the things that you look for, and how do you start? Like
I extract the meatballs from the spaghetti code. So while people are typing in, and Ryan is keeping track of that, there was a question from Matthew Newland. He says, Fab, I know you're a fan of unit tests, but can these be done on file IO and instrument IO sections modules? It definitely takes, and I could do a whole session on unit testing, but let me just say that it's something that you change the way you code. So the example that I like to give is a serial instrument, and actually on the book, that's the example that I use. I trust that the Visa functions from NI are going to be sending the information to the serial port. The part that I have control on is forming the protocol, parsing the protocol, interpreting the information. So I make those into sub VIs. That way, when the engineer, which we just went through that, the hardware engineer in the other room changed the start of frame and the end of frame and added extra bytes, I have unit tests that actually check for those things. It doesn't have anything to do with Visa or actually be connected to the instrument itself. It's just noting. Same thing with headers on files. If I know that I'm expecting a certain header on column 1, I have a unit test that checks for that. So in later, when we make other assumptions and we move that column around, I will have a unit test that will tell me you're breaking this code because this code assumes that this is the first column. So anyway, I can go on and on and on about that, but yes, it can be done, and it has to do more with extracting the part that you are creating outside of the connection with the instruments and the files.
Awesome. Yeah, we've got some other good questions in the chat. Some of them I'm going to save for the section on modifying code, and so I'm going to come back to those. So in the poll here, we've got some really good answers, kind of some themes around architecture, like trying to figure out the architecture or see the, what frameworks are used. Evidence of structure, any structure at all. Yeah, I've been there, know that. Understanding program flow. I think somebody had a good comment about find the main VI and map its hierarchy. And so, yeah, just kind of from the top down, trying to understand how does this application work, which for some applications is a lot easier than others. Looking for tests, looking for error handling, clean up the code. Go ahead.
Yeah, clean up the block diagram code is probably where I always start. And I'm not that big on documentation. I do a lot of in-program labeling, as it were, but I'm not a big documenter. But part of that cleaning up the block diagram would include quite a lot of what you would call classic documentation on the block diagram. What is it trying to tell me? What is it doing? And you go through it. And they may get deleted in the end once it tells its own story. But as you go through it, so that's probably the one that, as they came up, I looked at that and I thought, yeah, that's probably my starting point. Is clean up the block diagram.
I would even start one step before that and look at the repository or the zip archive or the folder, whatever you get from a customer, because I've had customers who gave me the project directory and it had like 3.5 gigabytes of stuff in it. And a lot of that was source code actually. And it was, of course, also installers and I don't know, documentation and whatever and whatnot. So the first thing I tried to figure out was, well, where do I need to start looking for the actual application? And maybe there are like we all know version 1 and version 2 and version 2 final and version 2 final and all these things that can happen. So even figuring out where's what also helps a lot, I think.
Yeah, the ultimate kahuna, the people from Mexico will understand this one. El mero mero patatero. Yeah, I mean I've seen those things. I start first to see if they actually gave me everything. I ask them if they actually have an option to build an executable. The very first thing that I try, even before I go into the back end, is can I make it work? So if they do have an executable, can I build the executable with what they gave me? Another thing is that I learned the hard way is I start on the LabVIEW version that they're using. I do not open on a newer version of LabVIEW because sometimes I had one situation where I kept telling the customer was missing something. They were not giving me a VI, and I had forgotten that from LabVIEW 8 to LabVIEW 2000, LabVIEW, I think it was LabVIEW 8, where one of the VIs that used to be public became private. And that's why the code was broken. So open it in the LabVIEW version that they're using, trying to build the executable on the installer first with what they give me, run the executable. If I get that far, at least I know that I have everything I need. The next thing is I use some automatic documentation generation applications. Is if they're using object-oriented programming, using the GDS toolkit to do some reverse engineering, may extract some good UML diagrams for me. If they are using DQMH, I can use Antidoc now, and that would show me some diagrams. And that's if they don't have already a documentation that shows me a high overview. I had a customer that he called me and he said, you're too expensive. And I was like, well, I can recommend you other people, or we can do 10 hours and then you decide. So he sent me the code and I ran it through GDS and I sent him back a description of the entire application. And he said, do you know Nate? And I'm like, I don't know who Nate is. It's like, there's no way in an hour you send me a whole description of what the application does. And I was like, look, Nate did very good job on his naming. I don't know if the code is actually doing what I'm telling you it's doing, but at least his hierarchy of classes and everything made sense. And I sent him the UML diagram and I explained how to read it. Well, till this day, you go to his lab and he has a picture of that UML diagram with a skeleton on top of it. And when I was there, I asked him, what is that skeleton doing there? And he said, that's the day I signed my soul to the devil. I'm going to choose to take that as a compliment because we have been working together for 10 years now. But it was that. It's just even before I opened a single VI, it was trying to get the 20,000 view picture of what the project was doing.
I think another aspect is building a repository if they don't have source code control, is making sure that the source code is related to the built application. One thing that drives me up the wall is the build, the executable build, which has nothing to do with the source code. Quite a few jobs I've gone into is they give you a separate lump of source code and then there's a build and you don't know one from the other.
I think
so
that's a really
it's just
good
making
point.
sure that you can recreate what they've currently got if it's a built executable system. Just making sure you can make it run the same way on your own systems, making sure that everything is in the repository and can be restored. So there's a lot of, I mean, as you alluded to, there's quite a lot of sort of housekeeping as well that you can do and be learning about the system as you do it, which is all. It's all being a good scout or girl guide or whatever, it's leaving it better than you find it.
And as you're going through these steps, this is your opportunity as a fresh eyes. What was the information that I was missing? So if there's no README or the README is out of date, this is your opportunity to update the README. And Jörg does even do something better. He starts a wiki for every project that he gets involved in.
Yeah, we started adding README files to all the repositories that we have and that we create too. I mean, listening to ourselves, all of this is just common sense. There's no rocket science here at all. But for some reason, you don't always think about all the common sense things that there could be. So still, it's worth iterating, I think, and reiterating and having a README file that tells you the first steps. So it tells you the LabVIEW version and which VI packages to install maybe, and where's the main VI. Simple things like that, they go such a long way in helping you get into it faster. And of course, for our project management stuff, we use the Doku Wiki for exchanging information with our customers, but also for ourselves and for the few open source things that we have. It's a very convenient thing to work with. It's a browser and you type stuff in, so it's no additional work at all. And you have one place to collect it. So something like that, I think, helps a lot.
But you have to do it as you go, because sometimes we say, oh, that's documentation, I'll do that later. Well, that's the same thing the person that before you did. They said, I'll eventually get to writing the README, and they never did it. Doesn't have to be written perfect English and with a nice font and all the company colors. You just need to say, I went to this link, I downloaded this driver, right? I put it here, and this is how I got the code to work. And every time we onboard someone new on our team that has to pick up a project, we tell them that, remember, this is our opportunity to get that README, like, perfect. So,
I want to expand on something that Steve talked about earlier about, it's what I would call like first do no harm. He talked about source code control. So one of the first things I do when I get code from a customer is put it into a source code control system. And that way, if I decide, I think these files are unused, I'm going to delete them. And then I, find out later why they were there and I can restore them back. Or if I want to start playing around and modifying some of the code to see if I understand it, then because I've kept it in source code control, then, I can always go back, or even just version changes. I've got, one project that the master code is in LabVIEW 5 and I'm going to be updating it to LabVIEW 2020. And so I want to be able to go back to that LabVIEW 5 code and convert it forward again if you know, I screw things up, or I just have questions about how things got converted a certain way. So I think that's a really important point. There's one question from
Brian,
the chat.
Please let me add one thing to the documentation stuff. So instead of answering an email by another email, type it into some place where you can like point other people towards. So in our case, type it into the DokuWiki, because the other 9 times that I get the same question, I can just send the link instead of typing it and remembering it.
And that goes to the Readme too, or the help file for your application. Yeah.
The other assumption here is that the code is working in the first place. 3 rescue jobs I've done in the last sort of 7 years, the programmer, in inverted commas, sat on the code for the project for months and months and months, and it wasn't functional. Wasn't even on the machine functional in one of them, and the hardware was still in its box. What you get as a benefit to that is a project that has run out of time as well, and none of the hardware has been tested. So you get added bonuses for such projects. So yeah.
So I brought up one of the questions from the chat. Is there a guideline written up that someone can follow as part of a path to success when dealing with jumble or garbage code? And in terms of an overall like guideline, you know, I think it depends. It kind of depends on where what's the situation with the code. You know, you kind of have to look at it. One of the things, and I think somebody already mentioned this, but the whole idea of block diagram cleanup. Yeah, I have to admit that I actually use that a lot when looking at other people's code, just because I don't always trust that they really wired up things the way that they appear to be wired. And block diagram cleanup will show me that, oh, you know, you've got a wire that's going under an icon when I thought it was wired into an icon. And so I don't necessarily keep the same version that's got block diagram cleanup, but I'll sometimes use that as a way to just like, let's spread out this code and try to see what, you know, what it's really doing according to LabVIEW. What do the rest of you think?
Well, we were doing more visual cues, but I don't think Brian was. You were looking at our screens. We were doing as far as more guides about how to deal with stuff. So
the common thing I tend to see is the massive block diagram. You get the massive block diagram, and
TVI.
Yeah. And that's a matter of really untangling. I think you have to untangle it step by step. Now, I mean, my particular technique would be I'd try to decouple the user interface stuff. So I'd add a loop for the user interface to be queued, stuff to be used, and then I'd be taking out all of the user interface updates and being able to begin to create some sort of modularity to and depth to the hierarchy, because normally you have a very it's an in-depth design thing, but you have the big block diagram is very, very shallow, hasn't got very many sub VIs, it doesn't go very deep. So one thing you would have to do is and reason people do that is because they have to update the front panel, so everything has to be up to the top. You know, and that's what makes these massive diagrams. Well, you don't actually have to work that way. You know, it's not. So that's the biggest challenge, I think, is untangling that massive big block diagram.
Brian and I were talking about this with a customer actually earlier this week about one thing that I think the 4 of us do is when we do recommend any way of addressing either inserting new technology or new ways of doing things, we try to find an area on the code where we can introduce these new concepts and still keep the rest. So in the case of Steve, he would do LabVIEW component, LabVIEW oriented, LabVIEW component oriented design, basically wrap some of the stuff on action engines on their own modules, if those meatballs do not exist among the spaghetti code in the VI, create those meatballs first. In my case, I do the DQMH modules because unlike other architectures out there, if you do something into a DQMH, it doesn't force you for everything to be a DQMH, but it allows you to start introducing modularity. And this is how I have convinced some customers that had the VI or had 2 or 3 the VIs to start introducing modularity, because when I show them that when they have a problem with that piece of code, we can run on the API tester, extract it from the code, test it on its own. After 2 or 3 or 4 years of dealing with them, they're like, okay, I think we're ready to start refactoring everything to be more like that. Once they experience on really small areas of the code, instead of trying to refactor everything at once.
And I think that's one of the things that I like about, I like doing those kind of surgical changes to an application of like, I don't have to refactor everything. I can just pick out the pieces I want to refactor. The other thing I was going to say about that is that sometimes you'll not necessarily make, like one of the things I was thinking about was I will sometimes put flat sequence structures around sections of code, not because I love flat sequence structures, but it gives me a way to like, let me start to figure out how this application really works. Like I think these VIs all kind of go together. These VIs kind of all go together. Those might be clues to where I could create some sub VIs, but it's okay if you make things messier before you clean them up the way that you really want to. Because I think you really kind of want to experiment, make sure you really understand before you start modifying code.
I tell the customers that we're on the part of the, when you're doing a remodeling at a house, we're at the part where we have to do demolishing and everything is dirty and everything is destroyed before we start actually bringing things in. But we still have to figure out a ways for making the rest of the house still livable, right? So
I think I need to write about it at some point, but the term I tend to use is block diagram time. The trouble with the massive block diagram is that it spans a great deal of block diagram time. It's doing a lot in that time, and data flow is doing a lot of hard work. And by wrapping things in sequence structures, what you're doing is framing a small part of block diagram time. And if you look at all of the DQMH, you look at the way that I do my loops. What it's doing is you're moving to very small bits of block diagram time that do very small bits, and then you can begin to understand it, because it's all about understanding in the end. And the massive block diagram is difficult to understand because it's doing a lot.
You know what, Steve? We're gonna give it here away, but we don't consider ourselves that smart to be able to handle on our brain the VI. So if you have smaller sections of code that you look at them and you can say, oh, this is what this thing is doing, then we are going to do better on maintaining the code and help others. So people say, oh, look how smart you are. And it's like, no, it's because I'm not smart and I cannot hold all that VI in my head that I need to make it into smaller pieces.
Yeah, which is why you're modularizing. But the point of the modularizing is you're getting something down into a small part that's only doing 5 things in your head. Then you can understand it. Then you're looking at another block diagram that's only doing 5 things. Then you can understand it. Up it goes. And that's generally what you're after.
Another thing that goes along with that is sometimes I feel like people try to make the amount of white color on the block diagram as little as possible. So moving all the things together as closely as possible, because probably that's the way to then have the biggest amount of stuff on your block diagram on your monitor. So I really like a lot of white space in between things so that I can understand how things are connected. So it doesn't make sense to try to cram everything into the smallest amount of space possible.
It's the style guide rule that you shouldn't exceed 1 page, and people just take it to go, right, okay, I'll cram everything into 1 page then. No, that's not the point.
There was a comment on the chat. The part of the remodel is usually where the contractor comes and asks you for more money. And so in defense of contractors, because I've had them work on my house, like they're coming to ask me for more money because they found termites or something like that. You've got a bigger problem that wasn't part of the original plan. And so, I think that's a lot of what we find is like, yeah, you asked for a simple little feature and here's why that feature is not so simple because we uncovered, some other problem in the code.
the typical, I just want a simple DAC application, and I'm only going to be acquiring 1 kilohertz at a time. And then once you give them the code, they're like, oh yeah, somehow this is it's not working when I'm acquiring 3.5 gigabytes a second. And it's like, wait a second, that's not what we agreed, right?
Okay, so I want to kind of wrap up this section and move on to section 3. So kind of my summary here is first, do no harm on assessing the code. Make sure you got good backups. I like to use source code control. Understand what you have. Try to find out if you have everything you're supposed to have. A lot of times you don't. Remind yourself, now's a good time to remind yourself why they brought you in. And like, what are they hiring you to do? Is it add a feature? Is it to modernize the whole application? Really kind of understanding that. And then don't modify the code until you at least think you understand the code. You may be wrong, but at least you can start to come up with conjectures about what the code does. And so when you get to the next section on modifying the code, you are at least trying to ensure that you're still making the code do what it needs to do, or maybe you're even modifying what your perception of the code, what it actually does. And then that you may need to iterate on that about, okay, I thought it did this, but it really does that. Do I really understand this application? So those are all steps that are important.
And when we get back to edit those slides, we need to add document as you go, since we spend so much time talking about that.
Yep. Okay, so you've kind of come up with your plan, and now you want to start modifying the code. What steps do you take? What's your plan of action?
That's where the IIIs start coming out of every corner.
Encapsulate common functionality, compartmentalization. Yeah. Talk to the team. Oh, I like that one.
Check for understanding, right? Like, okay, I just gave them what the plan is. Can you repeat it back to me? Are we really?
I have to say, some very good quality comments coming through. I think they should be doing
the presentation. Yeah,
they should be doing the presentation.
Yeah, test as you go. Definitely, that's a comment to my close to my heart.
Hey, Fabiola, why don't you talk about what if what if there's very few tests, or what if the tests are no good, or it seems like a early step to modifying the code is or maybe this goes in the assessing the code, is writing some tests.
Yeah, I was waiting for somebody to say that. So first, look if there are any stale tests. We all do this. We have a VI somewhere there called test, and sometimes you can find some really gems in there of what the developer was thinking when they put it. And if it still runs, then first of it run, because it gives you an idea what was the state of mind when they put certain VIs in order. And then the first thing I do is put those back in order, working on a unit test framework. And then before I do any refactoring, I create the test first, because I want to make sure that whatever change I make, the application or the piece of logic that I created, it still behaves like the previous one. So I think that's called regression testing, which means I am making sure that the test is there to warn me if I ever regress, meaning I go back instead of going forward in progress. So yeah, this is a good time to revive any stale tests that may be there and start creating tests.
Yeah, because tidying the project, the pruning the orphans and broken VIs, that's a good comment. Get a tip for that one.
And several people have mentioned the whole idea of, like working on small blocks, delivering.
I have a comment on the prune orphan VIs. You have to be careful about that one. What I do is I create a virtual folder on the project that's called to be deleted, because I think that, I did find VIs without colors and things start to get grouped there. But if you're using something like DQMH, all your API testers are going to be listed as orphan code. And you're going to be tempted, if you're just pruning without really paying attention, to delete them. And guess what? You just deleted a really key part of the code. May not be part of the final application, or it may be, but it is really key for the development. So don't go deleting just yet. Put
Or
it as
dynamically
part of
loaded
the-
VIs.
Yeah.
There's a period you go through. I've noticed when you're learning how to program LabVIEW where you fall in love with all things dynamic. So the pruning VIs is
Dangerous.
you have to be careful that there's not a million dynamic VIs being called. I've come to programs before where it has an architecture and everything's dynamic, and then the pruning VIs becomes very difficult because you don't know what the hell's calling what.
Look at the build specs. Sometimes in the build specification, they will have a list of always included VIs. So that's also a clue of things that are launched dynamically. And unfortunately, they find things without colors does not check on the build spec. Hey, there you go. If anybody puts that on the ID exchange, I'll go vote for it.
So I'm brutal with those kind of ones. Anything that's a dynamic VI gets put on the top level diagram in a empty case. So it becomes part of the main hierarchy of the main VI.
Yeah,
and I don't apologize for it at all.
That's another thing that I do with plugin architectures. Sometimes is to have a VI that actually you don't want to load it on your project because the objective of plugin architecture is not to load everything at once. But you want to have somewhere in a VI like the hierarchy of all your classes and everything. And it's really nice because LabVIEW is graphical, where you can actually do that on the block diagram, kind of like the VI tree that some instrument writers have.
Yeah,
so I want to bring up one of these things that's here about if it works, don't touch. And I think related is that XKCD of, whatever, it runs fine for now. So does a burning bus. So what's your feeling on if it works, don't touch it?
We first have to define works and the level of pain, right? Yeah. Like, because my customer that calls me every 2 years or so to do firefighting, he claims his code works. That doesn't fit my definition of works, but it fits his, right? So, but the example of the one where the thing was written in LabVIEW 4 with globals all over the place, my questions were, what are normally the headaches that you get with this application? What are the things that you have had issues with? Do you ever have to do any rebooting or stuff like that? And the answer to everything was no. The only reason they were calling me was because the computer started making funny noises and it was running Windows 95 and they were not going to be able to get a new computer. So it was really time to make sure that a new computer was brought in. So even though I didn't like the architecture, I didn't like the code, it really fit the definition of it works. They had not touched it since Windows 95. It's like the thing really works. So in that case, I just went through the porting steps to get it to, I think it was 2009.
So I'm not sure that I one of the things that if I don't understand why the code works, that's a problem.
Yeah.
I understand why it works, but it's like in that case, all the globals were write once, read many. So what they were doing, it was a simple monitoring application, and what they were doing is they were doing an acquisition with DAC, and then putting all the things on globals, and then in a different BI, they were reading from those globals and putting them on the screen. It was a very simple, straightforward application. And but it was all using globals. I would have never done it that from the beginning, but it was done a long time ago where there were no queues, there were no other things. They were acquiring at very slow speeds. So I think in that case, yes, I wish I could have done something nicer. When I asked them, what are the features that you foresee adding in the future? And they're like, no, we only need to add one more sensor. That's it. That we're done. And I'm like, okay, just one more sensor.
In that case, you understood how it worked. You just, knew where the landmines were. Yeah. There's some code I've looked at as like, really, I don't understand how this code works. And so I really feel like I do need to spend more time and get rid of the magic or document the magic about why it is that it is. One of my tricks was I would add comments that was like my conjecture about how this code works. In fact, I used to do that in the LabVIEW source code sometimes. Here's an undocumented subroutine. Here's my conjecture of what it does. And then I would try to prove whether my conjecture was right or not.
Yeah, and that's what I do with
I would definitely say if it's working and there's no reason to change it, there's no need to understand it at that point in time. So I would disagree actually, and I would say if it works, meaning it does what it should do, and there is no need to change it in the foreseeable future, then there's no need to even begin to understand it, unless you're already planning to rework it or to add a feature or whatever, because then it doesn't work anymore in the way you need it to work for you to do that. But in our case, working on customer projects, probably they're not going to pay us to change something that nobody's looking at the moment, and there is no imminent trouble to be foreseen. But then again, this is exactly the question of when does it work? What is it that it needs to do in order to be qualified to work?
And what means works, right? Because sometimes people will tell you, oh, but my application works great. You only have to restart it every 2 hours because you run out of memory. We only have to do, and you start asking that we only have to, and you start listing them, and then you have like, no, dude, you have all these issues. So when in that case with the globals, my question was, have you ever noticed that there's wrong data? Have you ever, right? Because I was thinking race conditions, like what are the land miles that this type of application could be foreseen? My only concern, and I did tell that to the customer, was that once I would put it into a faster computer and a newer version of LabVIEW, that any race conditions that had never been visible before would then show up at that time. So I did have to have some testing in plan to make sure that I could guarantee that there were really no race conditions and everything was still working as it was. But it goes back to the same thing. How am I going? What is my hypothesis of this? How this works? Then create a test to verify that my hypothesis was correct. Go make the modification and then verify that the code still does and then verify that my hypothesis was correct. So first, the current application as it is needs to pass my hypothesis, needs to pass my test. And then once it does, then I'll refactor and test it again.
There's a really good comment in the chat from Ravi. Talk to the operator because only he or she knows what all she has to do to make this stuff work.
Yes.
I think that's a really good comment of, there may be all sorts of like, oh, you have to click on this thing before you click on that thing, or, this doesn't work. And like understanding those and those undocumented tricks to making things work are really important.
Oh yeah, the typical, the manager who hired you says everything works. Then you go and sit down and observe the operator, and then the operator, you see, why are you doing that? Oh yeah, because I have to go to the task manager and kill the application every time because otherwise it won't stop.
And also the other way around. So I've seen that people are so thankful if you actually talk to them. So the people that actually operate the systems, because of course the designers and the developers and all the engineers, they know what they want to test. But the people that actually use the system, they're happy if you give them maybe something to store the default path of some file or whatever. So I've seen that they have very valuable input and nobody asks them. So I found that very interesting.
And sometimes it's really low-hanging fruit.
Yes.
Right. It's really, and this goes back to I want to measure the number of, oh, this is great, and smiles I see an operator or an end user do versus the when they get to use the application. Or like Steve would say, the measurement for a good code review is the number of WTFs coming out the door.
The statement that is if it works, don't touch is a fear-based statement, and I think any fear-based statement is a code smell. So if it's all of a bit black art, well, that's a fear-based statement. Don't touch it because it will break. Well, that just tells me that your code is far too tightly coupled. And these statements are worth being aware of, and when you are dealing with yourself, they're worth being aware of it. They're code smells. You should ideally, the ideal, I'm not saying we're dealing with ideals here, but the ideal is you should be able to touch everything.
Yeah.
That's what the aiming point is.
But I think there's a limit. There's an actual physical limit to the block diagram in LabVIEW. And the few people that know it is because we have had to deal with the VI, and I had one that I called the China cabinet because I swear I would move a wire and things would stop working, and it was because we were so close to the limit of the size and everything. There was also the other problem with it, and this is something that I didn't learn until years later, is that all the case structures, all the while diagrams, everything was set to not autogrow. So even though it was already scary, it was even scarier than what I could see, because there was code hidden behind what I couldn't see. You see what I mean with the auto grow? So that thing was scary. And yes, it like Steve says, that was a big sign. The fact that I couldn't move a wire, things were really, really, really bad.
Yeah,
Hey,
I mean, so my point is that it's a problem that needs rectifying. That's actually quite an important statement. Is that to me would be a little, oh, so what's wrong with this then?
Let me go touch it.
So there's a comment in the poll that I wanted to kind of touch on, and it says somebody suggested turn on automatic error handling and try to run the original code before modifying. So
No.
let me get on a soapbox about automatic error handling, because I am not a fan. But
Me
this is kind of an
neither.
interesting idea, because there's all these possible error outs that might be unwired. The main thing I don't like about automatic error handling is that it's an environment setting as much as it is a project or VI setting. And so if I give my code to somebody else and they have auto error handling enabled or disabled, it's opposite of mine, the application will not run the same on their computers. That's the main thing. I just don't like that facet of it. But I also just think that you should, I prefer to handle errors myself. But I do think this is an interesting idea of what if there's a whole bunch of errors happening that nobody just knows about? And automatic error handling and turning it on as an approach to understanding the code, maybe there's some merit to that. What do you guys think?
But there's a better way to do that, Brian, without the observer changing the observee. And that's with Desktop Execution Trace Toolkit. Desktop Execution Trace Toolkit would show you the errors without you turning error on. We had this issue with DQMH. We fixed it, where we were coding with automatic error handling off, and then people would create their templates with the DQMH template, and they started seeing things fail that we had never seen. And it was because they were turning on automatic error. So back to the being a VI setting versus a project setting, we now make sure that when you create a DQMH template, all the VIs that we created stay with automatic error handling off. So for those of you that turn it on just for a quick debugging, I suggest using Desktop Execution Trace Toolkit. That will show you all the errors, and you can even filter by error and show you every error, and then you can double click and it takes you to the location, and then you can decide, for this particular case, it's not handled. Do I want to handle it, or is it not handled because I really don't care about that error?
Yeah. Yep.
Monster. Serially saying that automatic error handling is a monster.
There was an earlier question. Let's see if I can bring it up. Any guidelines when porting between operating systems and LabVIEW versions? And kind of my thought on LabVIEW versions is I'm in the process of converting a LabVIEW 5 application to LabVIEW 2020. And it's a traditional DAC application that needs to be converted to DAC-MX. And so that's just sort of this, I had to go through this process of, let me mock up traditional DAC VIs in a modern LabVIEW, and some you can download, but some if you want to actually understand how they work, you kind of have to mess with their block diagrams. And so it was just an iterative process to do that. But the whole goal is to can I get this running the same way in LabVIEW 2020?
Serially saying he actually likes it's not a monster. Serial did say earlier it's good for people that know what they're doing, but it could be a lifesaver for beginners. Here's where I plug in Darren Nottinger's talk on an endless to brainless programming, or an end to brainless programming. He's going to be doing it for GLA Summit again, where he basically says you're giving them a crutch, where then they become too accustomed to the automatic error handling on, and then it goes off when you build the executable. So, it's really, I don't know. And I've been in my career, I've been in all the different scheme of the automatic error. I've been in the completely on all the time, completely off all the time. Well, it has its places. And right now I'm more in the off all the time. And if you want to turn it on, use Desktop Execution Trace Toolkit instead.
All right, I'm going to move on from this section. Let's say, so we talked about refactoring, reorganizing the code. You know, that's another thing of just like, you know, maybe create some folders and start to, or project libraries.
Or create a
to start
project. Sometimes they don't have a project.
Yeah, create a project, which we didn't have in LabVIEW 5. Figuring out what code could be in common sub-VIs that could be reusable. And then testing, just making sure that you are have some unit tests that you can run, so when you make changes that you can verify that you didn't break things that you had working before. Let's see. Okay, next poll. Planning for the future. So what are some things you can do to make the future better? And so that's some, you know, maybe it's future you, maybe it's the team that has to inherit this code. Type in some things into the poll to that are some ideas there.
Yeah, source code control. Yes, please. Please. Yeah, analyzer. Good. I think that LVOOP, if you have, but it has to come with LVOOD, meaning LabVIEW object-oriented programming has to be hand in hand with LabVIEW object-oriented design. If you're not doing both, you're doing it wrong. Source code control, yeah, documentation.
Make sure you're not the only person who knows the code base. That's a good.
Yeah, that's
I was gonna talk about the people aspect of things, you know, because one of the things that I really like to do is like train the team to support this better in the future. You know, like if they just had bad habits and they don't understand that they're bad habits, well, that's an area of training for the team about why it's a bad habit and how to not do that in the future.
Yeah, there's a lot of like even the automatic error handling on or off, all of those things. I try when I teach the advanced architectures in LabVIEW course or when I'm working with a customer, I try to explain why something bugs me and why are the reasons that I don't think that's a good practice. If people don't understand why you're asking them to do something, they're going to go back to the bad habit. Now, if you can simulate living through the pain that you are trying to tell them that they're going to have an eventual point, that's going to be even better. Sometimes they just don't believe you, right? So one thing we do when we work with customers is if they say that they're going to be maintaining the code and they want to maintain the code, we ask that they are members of the team as well. So they even if they don't program, they have to be at the code reviews. They have to be at the beginning when we decide the sprint. They have to be at the end when we're doing the retrospect or the show and tell. And they have to be at the code reviews because it is really hard to go at the end and then explain all the decision and the trade-offs that went into each one of those code reviews. So that way that at least they have an idea of why we ended up with the architecture that we ended up with.
And the same goes, I think, for the style and for the way of working as much as for the code itself. So many people know that there are style guides, but I think they don't actually bother looking at them. And then when we show them, okay, we've written down like the most important things we want to follow, whatever they are, people say, oh, that's actually a handy thing, so I can read up on that. And I know that you go even a step further, Fab, by creating customized style guides and the VI analyzer tests to go along with them for your customers. So if the team is planning on picking up the work, it's really worth your while to show them how they can make their own lives easier by following common rules, whatever they are. They can be elaborate or very simple.
And when we give them those style guidelines, we say, this is just a springboard. We have to work with you to make sure that you like it. It's not like, oh, because Fab says or because Delacour says that we should do it this way. Like, for example, we have naming conventions. We do the -- cluster -- enumerator for all our controls. And the reason we do that is if you use quick drop, it's a lot easier to do control space -- enum and see all the enums that are on your project. So that there's a reason why we do it that way. And we have a custom VI analyzer test that double checks that if the name says -- enum, that there is an enum indeed. in the control and not a ring, for example. So there are things that you can do where you can have BI Analyzer help you enforce or encourage your style guidelines without the tech lead having to be breathing over people's shoulders to remind
So
them
there's a
about
question in the chat. How have you helped people that need to shed the bad habits and get them to buy into doing things the correct way?
For me, the answer is be willing to be patient and work on it on the long haul and pick your battles. You're not going to have them shed all their bad habits at once, especially if they have been acquired through years of working a certain way. So I like I said earlier, I try to show why something is bad. I'm trying to think of an example. Well, the not using the analyzer, that's an easy one. I have a couple of example code where I show it to them, and then I say, okay, what's wrong with this code? And they're not able to tell me. And then I run the VI analyzer test and I show them why those things are dangerous. So sometimes it will take a couple of times. The testing, the having API testers and the having unit tests and doing diagrams before we start coding, it's just. I had one customer once say, I'm hiring you to code, not to do flow diagrams and tests. And I was like, okay, here's the thing, right? We're going to do it your way, but I'm going to choose an architecture that's going to seem overkill to you, just because that's where I feel more comfortable and I think it's going to be able to get me out of corner cases. And also, I am going to tell you, I'm telling you right now, everybody tells you never tell people I told you so, but I'm telling you right now, I'm going to tell you I told you so every time we get into a corner case because we didn't do things my way. So I don't know how many times I said I told you so, but it probably was enough times that the next time I work on a project with that customer, he sent me an email saying, please find attached the flow chart, the flow diagram, the interviews with end users, all this stuff that I normally do, because now I know that saves me money. So it was me willing to take a project with someone and do it their way, but with that understanding that and asking for the permission ahead of time that I'm going to be pointing out why, right? Because you're not believing me now. You're not. So we're going to go it your way. You're doing an informed decision, and I don't feel like I'm stealing from you because you're doing an informed decision. Now let's see you suffer through it and point out when you're suffering through it, so the next time you want to do it better.
And to add to that, I think it works best if you're able to do it in a very constructive way and show the benefits and not so much point out how something is wrong, but to say, well, think about it from that way. If we use it like this, we could even gain that positive effect or whatever. So people are much more likely to buy into that, because it doesn't mean that they did it wrong, but there's always something you can do better for everybody, for any one of us. So that's easier then.
And not trying to do everything. You don't want to fix everything. And one of the things that I get a lot when people hire me is like, oh, Fab, but you love unit testing. I really want to understand unit testing. And I'm like, yeah, but you don't have source code control. So let's get that first, and let's get you to your working code, and I'll get you to the unit testing. But first things first, right?
So here's another good question from the chat.
Describe why a particular thing is beneficial. You can't say why it's an advantage or it has a disadvantage. If you can't enumerate that, then it's probably not that important. So it's actually quite easy to get people to work in a particular way because there's good reasons to do it. Now, if there isn't good reasons to do it, don't do it. So if you're just saying, I'll take a couple of examples, use this technique. Yeah, well, there's got to be a reason. What's the benefit? What's the payback for me doing that? And you have to answer that question, whether it even be to yourself, but you have to answer that question to your customer. And if you can't, then they ain't going to pick it up, But it should be fair. I mean, generally, leading by example is enough for most programmers. If you say, look, here's why we do this, and if you don't do it like this, this is what's going to happen, which goes back to the I told you so. But I mean, a lot of these things are fairly simple to sort of enumerate. If you say that if you're going to link everything, then that your whole architecture is going to get very brittle, and this and this is going to happen. Well, these are the ways you stop that particular thing happening. I'd like to, outside of answering that question, one thing I did try and get a word in is bug and feature tracking. I think I'd like to add on to that. Version control rather than source code control, but version control, bug feature tracking, linking the issue tracking number using bookmarks when you're doing this kind of thing is really, really helpful. So if you make a change in the code, use a bookmark to say, I'm fixing this issue. This issue we've put in our issue tracking system, it's got a number, this is where we fix it. And so as you're building traceability through the code then of what you're doing. So there's a couple of comments that you could link together, which was using bookmarks for comments, but I would use bookmarks for issue tracking as well. There's
some good discussion happening in the chat. Started with this question from Casey. Anyone have good suggestions for how to document the accumulation of technical debt that managers might want to take on? And there's been some discussion. Elaine mentioned risk matrices. Chris Ralph also chimed in on that one. So what are some thoughts there on going back to management in saying, like, here's this risk that you're carrying forward, what is your plan for dealing with that?
So my thing, I did a presentation on focusing on technical wealth instead of technical debt. That there's two versions of it, one from CLA Summit and one from NI Week. One of the things that I try to understand is what's the value that those managers see. And that's going to be different for company to company. There's going to be companies that are the management is going to put everything in terms of hours per developer, where in other companies that means nothing. They see the time that a developer is spending as free money because they're already paying for it, whether they use it or not. So you have to figure out what's valuable. One thing that I learned from Brian was understanding what are the goals of the company, and where that manager's own goals, what they're going to be reviewed against, it aligns with the goals in the company. If you find a way of translating what you want to change in those terms that align directly with those goals, bonuses, or anything like that, you are halfway through. It is an art. It's not. There's not a science to it, but that's the best way to.
Just to expand on what I meant by that. So, like one company I worked with, there was a test director who was. I knew he was compensated basically on the cost of reducing the cost of test in his company, and so I could go to him and say, "Here are some things that I believe you need to do, and here's the savings on." What it would cost to test a new product or make changes or throughput, things like that, and those directly impact his review at the end of the year. And so he was very interested in making some of those changes because I put it in the terms that he understood.
Yeah, everything comes down to return on investment, really. So I've always found the easiest is downtime of the machine. I mean, that's really, if you're in a factory, downtime of the machine is really expensive. So you can get pretty much anything paid for using that metric. It's a great one.
Oops. Let's see. So we're about out of time. Let me kind of wrap up here, planning for the future. Are the people and process issues repaired, or do you at least have a plan for fixing those? Making sure the code is maintainable. One of the other things we didn't talk about so much is this, like, can we reproducibly build the artifacts when we leave? Like we left it in a good state and I can prove it is a good thing. And so I want to briefly hand it back to Jeremy to wrap up the recorded part of this. I think we're going to hang on a little bit more and we can answer more questions on the chat. Jeremy?
Hey, thanks, Brian. So first, I want to thank our speakers, Brian, Fabiola, Steve, and Jorg. They did a fantastic job. I also want to thank our live stream producer in the background and LabVIEW architect, Derek Bomarito. And I also want to point out an excellent online event coming up in early November. So as most of you know, the in-person Certified LabVIEW Architects Summits were canceled this year, but community organizers have taken the event online as the Global LabVIEW Architect Summit. It's open to all. So go see glasummit.org for details on that. It is early in November, and it's a 24-hour marathon of events for all time zones. And So you should hear lots of good speakers and get lots of good information there.
And it is worth it to attend person. Just want to say that it is virtual. It's going to be recorded, but please try to actually make it because there's going to be a lot of interaction.
Yes, definitely. If you have a topic you'd like to share, please message me on LinkedIn, or if you have topics that you'd like to hear about, you just go to my LinkedIn page and message me there, and we can start a conversation. This was our final LabVIEW live event for 2020, but stay tuned for 2021 where we'll be bringing you a lot more valuable content like this. So thanks for watching. Please hang out in the chat. We will keep chatting and answering questions interactively. But for those of you that have to go, we will see you next time. Thanks.
Thanks for having us, Jeremy and G Systems.
Yeah, thank you.
Thank you.
That's very good. Thank you.